Hello everyone, I am back here with a wonderful video which helps you a lot before attending any competitive exam. It will be related to your on-campus placements, off-campus placements, or it may be any bank, PO, SBI, PO, IBPS or BI exam, MBA, MAT, CAT, IIFT, IGNOU, Hotel Management, SSC Combined Preliminary Exam, Sub-Inspector of Police, CBI, CPO exam, Railway Recruitment Board exams, finally Campus Recruitment Test. So, here I am going to explain the concepts of each topic in depth and also formulas, key points to remember in each and every topic. So let's take 2 minutes gap after each topic. So in the 2 minutes you can recall how much concept has entered into your brain. You all can think of this. We can do that anytime. But I am serious about giving you all a pretty simple task. It's also a wonderful learning tip I can say. When you learn something, close your eyes for a while and memorize what you learned today. Then it will be stored in your mind constantly. Concepts are simple. When it comes to application, you just have to think you know all. You learned everything. So let's jump into our first topic, number theory. Here, you all know that various types of numbers, natural numbers, whole numbers, integers, even numbers, odd numbers, prime numbers. A counting number is called a prime number if it has exactly two factors, namely itself and 1. You all know that very well. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and so on. Composite numbers. The natural numbers which are not prime are called composite numbers. Coprimes. Two natural numbers A and B are said to be coprime if their HCF is 1. Example 2, 3, 4, 5, 7, 9, 8, 11, etc. or pairs of coprimes. This is our first topic. It's simple to all know. And next, HCF and LCM of number. You know HCF, highest common factor. LCM is multi lowest common multiplier or common division method, shortcut method of finding LCM. Common division method, shortcut method of finding LCM. LCM, least common multiple. Here the key points to remember are product of two numbers equal to product of their HCF and LCM. Coprimes. Two numbers are said to be coprimes if their HCF is 1. HCF equal to HCF of numerators divided by LCM of denominators. LCM equal to LCM of numerators divided by HCF of denominators. This is about HCF and LCM. Next, decimal fractions. You all know how the decimals are represented and conversion of a decimals. So on so. Some basic formulas to remember here. A plus b into a minus b equal to a square minus b square. A minus b whole square equal to a square plus b square minus 2ab. A cube plus b cube equal to a plus b into a square minus ab plus b square. A cube minus b cube equal to a minus b into a square plus ab plus b square. A cube plus b cube plus c cube minus 3abc equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. When a plus b plus c equal to 0, then a cube plus b cube plus c cube equal to 3abc. A plus b whole square equal to a square plus b square plus 2ab. a plus b plus c whole square equal to a square plus b square plus c square plus 2 into ab plus bc plus ca is so enough here. So let's jump into fourth topic, but simplification. In simplification, board mass. You all know the board mass rule, I guess. B means bracket, O for off, D for division, M for multiplication, A for addition, and S for subtraction. Here, modulus of a real number A is defined as modulo A equal to A if A greater than A minus A if A less than A. Vernaculum or bar. Before going to vernaculum or bar, modulo 5 equal to 5 and modulo minus 5 equal to minus of minus 5 equal to 5. Both are 5. Both becomes positive because A greater than 0. Vernaculum bar. Here, vernaculum nothing but bar. When an expression contains vernaculum, before applying the Bournemouth rule, we simplify the expression under the vernacular. This is simplification. Next, square roots and cube roots. Square roots. If x square equal to y, we say the square root of y is x, and we write root y equal to x. Thus, root 4 equal to 2, root 9 equal to 3, root 196 equal to 14. Cube root. The cube root of a given number, x is the number whose cube is x. We denote the cube root of x by 3 cube x. Cube the root of x. Thus, cube the root of 8 equal to cube root of 2 into 2 into 2, like that. Root of xy equal to root x into root y. Root of x divided by y equal to root x divided by root 1. Square roots and cube roots completed with with this concept. Average. Here, average equal to sum of observations divided by number of observations. Suppose a man covers a certain distance at x kilometer and an equal distance at y kilometer. Then the average speed during the whole journey is 2xy divided by x plus y kilometer per hour. Next, problems on numbers. And let's jump into next topic. Profit and loss. Yeah, this is our topic now. Before profit and loss, uh, search and indices. Here, loss of indices a power m into a power n equal to a power m plus m. A power m divided by a power n equal to a power m minus n. A power m whole power n equal to a power mn. AB whole power n equal to a power n into b power n. A by b whole power n equal to a power n divided by b power n. Anything power 0 equal to 1. A power 0 equal to 1. Search. Let a be a rational number and n be a positive integer such that a power 1 by n equal to nth root of a is irrational, then nth root a is called a surd of order n. Loss of surds. Nth root a equal to a power 1 by n. Nth root ab equal to nth root a into nth root b. nth root a by b equal to nth root a divided by nth root b. Nth root a whole power n equal to a. Nth root a equal to mn whole power mnth root a. Nth root a whole power n equal to nth root a power n. Next, profit and loss. Cost here, important fact. Cost price. The price at which an article is purchased is called the cost price, abbreviated as CP, selling price. The price at which an article is sold is called the selling price, abbreviated as SP. Profit or gain. If selling price is greater than cost price, the seller is said to have a profit or gain. Loss. If selling price is less than cost price, the seller is said to have incurred a loss. Formulas: gain equal to selling price minus cost price. Loss or gain is always recorded depends on cost price. Gain percent equal to gain by cost price into 100. Selling price equal to only uh, if you remember one formula, then everything derived from it. Just remember gain equal to selling price minus cost price, loss equal to cost price minus selling price. Remaining all you can derive from it. If an article is sold at a gain of say 35%, then selling price equal to 135% of cost price. If an article is sold at a loss of say 35%, then selling price equal to 65% of cost price. Here gain, then we are adding 100 to the given percentage. When it comes to loss, subtracting from 100, uh, subtracting a given value from 100, that's called loss. When a person sells two similar items, one at a gain of say X% and other at a loss of X%, then the seller always incurs the loss given by loss percent equal to common loss and gain percent divided by 10 whole square. X by 10 whole square. X is here as X is common loss and gain percent. If a trader professes to sell his goods at cost price but uses false weights, then gain percent equal to error divided by true value minus error into 100 whole percent. That's profit and loss concept. Yeah. Next, ratio and proportion. Ratio, the ratio of two quantities denoted by A is to B, A by B. You know that. In the ratio A is to B, we call A as the first term or antecedent and B the second term or consequent. Example, the ratio 5 is to 9 represents 5 divided by 9 with antecedent 5, consequent 9. Rule: the multiplication or division of each term of a ratio by the same non-zero number does not affect the ratio. Example, 4 is to 5 equal to 8 is to 10 equal to 12 is to 15, etc. Proportion: the equality of two ratios is called proportion. If A is to B equal to C is to D, we write A is to B is to C is to D, and we say that A, B, C, D are in proportion. Here A and D are called extremes. while B and C are called mean terms. Product of means equal to product of extremes. Thus, A is to B is double is to C is to D. That implies B into C equal to A into D. Fourth proportional. If A is to B equal to C is to D, then D is called the fourth proportional to A, B, C. Third proportional. If A is to B equal to B is to C, then C is called the third proportional to A and B. Mean proportional. Mean proportional between A and B is root AB. Comparison of ratios. We say that A is to B greater than C is to D. A by B greater than C by D. Compound ratio. The compound ratio of ratios A is to B, C is to D, E is to F is A, C, E is to B, D, F. Duplicate rate ratio of A is to B is A square is to B square. Sub-duplicate ratio of A is to B is root A is to root B. Triplicate ratio of A is to B is A cube is to B cube. Sub-triplicate ratio of A is to B is A power 1 by 3 divided is to B power 1 by 3. If A by B equal to C by D, then A plus B divided by A minus B equal to C plus D divided by C minus D. Componendo and dividendo rule. I will repeat again. If A by B equal to C by D, then A plus B divided by A minus B equal to C plus D divided by C minus D. This is componendo and dividendo variation. We say that x is directly proportional to y if x equal to ky for some constant k, and we write x directly proportional to y. We say that inversely proportional if xy equal to k for some constant k, and we write x inversely proportional to y. X proportional to 1 by 9 is x inversely proportional to y. Next, partnership. Yeah, when in this partnership topic, when two or more than two persons run a business jointly, they are called partners, and the deal is known as partnership. Ratio of division of gains. When investment of all the partners are for the same time, the gain or loss is distributed among the partners in the ratio of their investments. Suppose A and B invest rupees X and rupees Y respectively for a year in a business. Then at the end of the year, A's share of profit is to B's share of profit equal to X is to Y. When investments are for different time periods, then equivalent capitals are calculated for a unit of time by taking capital into number of units of time. Now, gain or loss is divided in the ratio of these capitals. Suppose A invests rupees X for P months and B invests rupees Y for Q months. Then A's share of profit is to B's share of profit equal to XP is to YQ. And next point, final point to remember in this partnership concept, working and sleeping partners. A partner who manages the business is known as a working partner, and the one who simply invests the money is a sleeping partner. Jumping into another topic, chain rule. Direct proportion. Two quantities are said to be directly proportional if one of the increase or decrease of the one, the other increases. If one increase or decrease, then the other increase or decrease to the same extent. That's direct proportion. Example, cost is directly proportional to the number of articles, more cost. Work is directly proportional to the number of men working on it. More men, more work. Indirect proportion. The quantities are said to be indirectly proportional if one of the increases, the other decreases to the same extent and vice versa. Example, the time taken by a car in covering a certain distance is inversely proportional to the speed of the car. More speed, less is the time taken to cover a distance. Time taken to finish a work is inversely proportional to the number of persons working at it. More persons, less is the time taken to finish a job. Remark, in solving questions by chain rule, we can compare every item with the term to be found out. This is chain rule. Next, time and work. If A can do a piece of work in n days, then A's 1 day's work equal to 1 by n. If A's 1 day's work equal to 1 by n, then A can finish the work in n days. If A is thrice as good a workman as B, then ratio of work done by A and B equal to 3:1. Ratio of times taken by A and B to finish a work equal to 1:3. These were time and work. And the next topic, pipes and systems. Here, two words to remember, inlet and outlet. Yes, inlet, a pipe connected with a tank or a cistern or a reservoir that fills it. It is known as an inlet. Outlet, a pipe connected with a tank or a cistern or a reservoir emptying it is known as an outlet. If a pipe can fill a tank in H hours, then pot filled in 1 hour equal to 1 by H. If a pipe can empty a full tank in Y hours, then pot emptied in 1 hour equal to 1 by Y. If a pipe can fill a tank in K hours, X hours, and another pipe can empty the full tank in Y hours, where Y greater than X, then an opening both pipes, opening both the pipes, the net pot filled in 1 hour equal to 1 by x minus 1 by y. If a pipe can fill a tank in x hours and another pipe can empty the full tank in y hours, where x greater than y, then an opening both the pipes, the net pot emptied in 1 hour equal to 1 by y minus 1 by x. Next topic, time and distance. Here important facts and formulas to discuss. Speed. Speed equal to distance by time. Time equal to distance by speed. Distance equal to speed into time. X kilometer per hour equal to x into 5 by 18 meter per second. X meter per second equal to x into 18 by 5 kilometer per hour. If the ratio of the speeds of A and B is A is to B. Then the ratio of the times taken by them to cover the same distance is 1 by A is to 1 by B or B is to A. Suppose a man covers a certain distance at x km per hour and an equal distance at y km per hour. Then the average during the whole journey is spread by divided by x plus y km per hour. Yeah, that's time and work. And our next topic problems on trains. A kilometer per hour equal to A into 5 by 18 meter per second. Same the formula is here because it is used there and also here. A meter per second equal to A into 18 by 5 kilometer per hour. That means 1 meter per kilometer 1 meter per second equal to 18 by 5 kilometer per hour. 1 kilometer per hour equal to 5 by 18 meter per second. Time taken by a train of length L meters to pass a pole or a standing man or a signal post is equal to the time taken by the train to cover L meters. Time taken by train of length L meters to pass a stationary object of length B meters is the time taken by the train to cover L plus B meters. Suppose two trains or two bodies are moving in the same direction at u meter per second and v meter per second, where u greater than v, then the relative speed equal to u minus v meter per second. Suppose two trains or two bodies are moving in opposite directions at u meter per second and v meter per second, then the relative speed is u plus v meter per second. If two trains of length a meters and b meters are moving in opposite directions at u meter per second and v meter per second, then time taken by the trains to cross each other equal to a plus b divided by u plus v seconds. If two trains of length a meters and b meters are moving in the same direction at u meter per second and v meter per second, then the time taken by the faster train to cross the slower train equal to a plus b divided by u minus v seconds. If two trains or bodies start at the same time from points A and B towards each other, and after crossing they take A and B second in reaching B and A respectively, then A speed equal is to B speed equal to root B is to root A. This is the concept here. Next, boats and streams. In water, the direction along the stream is called downstream and the direction against the stream is called upstream. If the speed of a boat in still water is u km per hour and the speed of the stream is v km per hour, then speed downstream equal to u plus v km per hour, speed upstream equal to u minus v km per hour. If the speed downstream is a km per hour and the speed upstream is b km per hour, then speed in still water equal to 1 by 2 into a plus b km per hour. Rate of stream equal to 1 by 2 into a minus b km per hour or a minus b by 2. That's same. And next topic, allegation or mixture. Here, allegation. It is the rule that enables us to find the ratio in which two or more ingredients at the given price must be mixed to produce a mixture of a desired price. Mean price The word mean price means the cost price of a unit quantity of the mixture is called the mean price. Rule of alligation: if two ingredients are mixed, then quantity of cheaper by quantity of dearer equal to cost price of dearer minus mean price divided by mean price minus cost price of cheaper. Suppose a container contains X units of liquid from which Y units are taken out and replaced by water. After n operations, the quantity of pure liquid equal to X into 1 minus y by x into 1 minus y by x whole power n units. This is allocations or mixture. And next topic, simple interest. Here, three words you have to remember: principal, interest, simple interest. Principal: the money borrowed or lent out for a certain period is called the principal or the sum. Interest: extra money paid for using others' money is called interest. And the simple interest: if the interest on a sum borrowed for a certain period is depends uniformly, then it is called simple interest. Let principal equal to P, rate equal to or percent per annum, and time denotes T in years. Then simple interest equal to P or T by 100. You can derive remaining formulas from these. If, if simple interest equal to PRT by 100, P equal to 100 into simple interest divided by R into T, rate into time. Rate equal to 100 into simple interest divided by principal into time. And time equal to 100 into simple interest divided by principal into rate. The one and only formula is simple interest equal to PRT divided by 100. And our next topic is compound interest. Sometimes it so happens that the borrower and the lender agree to fix up a certain unit of time, say early or half yearly or quarterly, to settle the previous account. In such cases, the amount after first unit of time becomes the principal. For the second unit, the amount for second unit becomes the principal for the third unit, and so on. After a specified period, the difference between the amount and the money borrowed is called the compound interest, abbreviated as CI, for that period. Important facts and formula: same notations used here: principal, rate, and time. And when interest is compound annually, formula is amount equal to P into 1 plus or by 100 whole power n. When interest is compounded half yearly, amount equal to P into 1 plus or by 2 divided by 100 whole power 2n. Or and n values replaces. When annually, it is or by 100 and n. Half yearly, or by 2 to n. Quarterly, or by 4n. Third changes: when interest is compounded annually but time is in fractions, say 3 into 2 by 5 years. Here amount equal to P into 1 plus or by 100 whole cube into 1 plus 2 by 5 or by 100. This you have to remember here in compound interest. Next, we jump into logarithms. We all learned from history. Yeah, it will be easy. Logarithm. If a is a positive real number other than 1 and a power m equal to x, then we write m equal to log x to base a. If a power m equal to x, then we write m equal to log x to base a. And we say that the value of log x to the base a is m. Example, 10 cube equal to 1000. Now we write this as log 1000 to base 10 equal to 3. One more example, 3 power 4 equal to 81. This written as log 81 to the base 3 equal to 4. 2 power minus 3 equal to 1 by 8. It written as log 1 by 8 to base 2 equal to minus 3. So the formula is if a power m equal to x, then m equal to log x to base a. And properties remember here are log xy to base a equal to log x to base a plus log y to base a, and log x divided by y to base a equal to log x to base a minus log y to base a. Log x to base x equal to 1. Same base equal to 1. We know that. Log 1 to base a equal to 0. It is also written as log 1 to base a equal to 0. A power 0 equal to 1. Next, log x power p to the base a equal to p into log x to base a. The power comes to front and it multiplies. That's the logic. Log x to base a equal to 1 by log a to base x. When you write reciprocal, the base and the power value changes. Log x to base c equal to log x to base b divided by log a to base b. You can write like this also. Log x to base b, log x to base a equal to log x to base b divided by log a to base b equal to log x divided by log a. Remember, when base is not mentioned, it is taken as 10. Common logarithms. Logarithms to the base 10 are known as common logarithms. Characteristic. For characteristic, the logarithm of a number contains two parts, namely characteristics, stick and mantissa. Characteristic. The integral part of the logarithm of a number is called its characteristic when the number is greater than 1. In this case, the characteristic is 1 less than the number of digits in the left of the decimal point in the given number. Case 2. When the number is less than 1. In this case, the characteristic is more than the number of zeros between the decimal point and the first significant digit of the number. And it is negative. Instead of minus 1, minus 2, etc., we write 1 bar, 2 bar. So, mantissa, the decimal part of the logarithm of a number is known as mantissa. For mantissa, we look through log tables. This is all about logarithms. And the next topic, area. Area results on triangle Sum of the angles of a triangle is 180. The sum of any two sides of a triangle is greater than the third side. Pythagoras theorem. In a right angled triangle, hypotenuse square equal to base square plus height square. The line joining the midpoint of a side of a triangle to the opposite vertex is called the median. The point where three medians of a triangle meet is called centroid. The centroid divides each of the medians in the ratio 2:1. Next point, in an isosceles triangle, the altitude from the vertex bisects the base. The median of a triangle divides it into two triangles of the same area. The areas of the triangle formed by joining the midpoints of the sides of a given triangle is one-fourth of the area of the given triangle. And also here, results on quadrilaterals. To remember, this is also important. The diagonals of a parallelogram bisect each other. Each diagonal of a parallelogram divides it into two triangles of the same area. The diagonals of a rectangle are equal and bisect each other. The diagonals of a square are equal and bisect each other at right angles. The diagonals of a rhombus are unequal and bisect each other at right angles. A parallelogram and a rectangle on the same base and between the same parallels are equal in area. Of all the parallelogram of given sides, the parallelogram which is a rectangle has the greatest area. And important formulas in areas concept area of a rectangle length into breadth. Length equal to area divided by breadth and breadth equal to area divided by length. Perimeter of a rectangle equal to 2 into length plus breadth, 2 into L plus B. Area of a square equal to side square, half into diagonal square. Area of four walls and of a room equal to 2 into L plus B into H. 2 into length plus breadth into height. Area of a rectangle half into base into height. And area of a triangle root of s into s minus a into s minus b into s minus c, where a, b, c are the sides of triangle and s equal to half into a plus b plus c. Heron's formula. Area of an equilateral triangle equal to root 3 by 4 side square. Radius of incircle of an equilateral triangle of side a equal to a by 2 root 3. Radius of circumcircle of an equilateral triangle of side a equal to a by root 3. Radius of incircle of a triangle of area and semi of area and semi perimeter s equal to delta by s. Here triangle area denoted by delta, semi perimeter s. Radius of incircle of a triangle of area delta and semi perimeter s equal to delta by s. Area of a parallelogram equal to base into height. Area of rhombus equal to half into product of diagonals. Area of trapezium half into sum of parallel sides into distance between them. Area of circle pi r square where r is radius. Circumference of a circle equal to 2 pi r. Length of an arc equal to 2 pi r theta divided by 360, where theta is the central angle. Area of a sector equal to half into arc into capital R, pi r square theta by 360. Area of a semicircle equal to pi r square by 2. Circumference of a semicircle equal to pi r. These are the formulas to remember the area concept. And jump to next topic. Volume and surface area. Let's start with it. Here, cuboid, let length L, breadth B, and height H units. Then volume equal to L B H, L into B into H, cubic units. Surface area equal to 2 into LB plus BH plus LH, 2 into length into breadth plus breadth into height plus length into height. Square units. Surface area denotes in square units. Diagonal equal to root of L square plus B square plus H square units. These are cuboid volume surface area diagonals. Next, cube. Let each edge of a cube be of length A. Then volume equal to A cube, surface area equal to 6 A square square units. Diagonal root 3A units. Cylinder. Let radius of base equal to R and height or length equal to H. Then volume equal to pi r square H cubic units. Curved surface area equal to 2 pi r H square units. Total surface area equal to 2 pi r H plus 2 pi r square units. You can take common 2 pi r and write it as 2 pi r into H plus R. Total surface area of a cylinder 2 pi r into H plus R. Next, cone. Let radius of base equal to R and height H. Then slant height L equal to root of H square plus R square units. Volume equal to 1 by 3 pi r square H cubic units. Curved surface area equal to pi r L square units. Total surface area equal to pi r L plus pi r square units. Sphere. Let the radius of the sphere be r, then volume equal to 4 by 3 pi r cubic units, surface area equal to 4 pi r square units. Hemisphere. Here, let radius of a hemisphere be r, then volume equal to 2 by 3 pi r cubic units, curved surface area equal to 2 pi r square units, total surface area equal to 3 pi r square units. Remember, 1 liter equal to 1000 centimeter cube. These are volume and surface area concepts. Next concept is races and games of skill. You know about race sports, winning point or goal winner, dead heat race, start, games. These are the keywords. You know about this. So I jump into calendar. Calendar topic. We are supposed to find the day of the week on a given date. For this, we use the concept of odd days. Odd days, in a given period, the number of days more than the complete weeks are called odd days. And next, leap year. Every year divisible by 4 is a leap year. If it is not a century, every fourth century is a leap year, and no other century is a leap year. Note, a leap year has 366 days. Example, each of the years 1948, 2004, 1676 is a leap year. Each of the years 400, 800, 1200 leap years. None of the years 2001, 2002 also leap year. Ordinary year. The year which is not a leap year is called an ordinary year. An ordinary year has 365 days. Counting of odd days. One ordinary year equal to 365 days. 365 days equal to 52 weeks plus 1 day. One ordinary year has one odd day. One leap year equal to 366 days. 52 weeks plus 2 days. One leap year has 2 odd days. 100 years equal to 36 ordinary years plus 24 leap years. 124 odd days. 100 years equal to 124 odd days. You can write is 76 into 1 plus 24 into 2. Ordinary days into 1, leap years into 2. So, these are the possibilities here. And next topic is stock and shares. Here, the key points are stock capital, shares or stock, dividend, face value, market value, uh, brokerage. Remember, the face value of a share always remains the same. The market value of a share changes from time to time. Dividend is always paid on the face value of a share. Number of shares held by a person equal to total investment divided by investment in one share equal to total income divided by income from one share equal to total face value divided by face value of one share. Thus, rate of interest equal to annual income from an investment of rupees 100. This is from an example output. So let's leave this. To get to know why solving problems. Our next topic, permutations and combinations. Factorial notation. And you all know permutations, combinations, factorial notation. It means let n be a positive number, then factorial n denoted by n factorial is defined as n factorial equal to n into n minus 1 into n minus 2 and so on, 3 into 2 into 1. 5 factorial equal to example 5 into 4 into 3 into 1, 120. 4 factorial 4 into 3 into 2 into 1, 24. We define 0 factorial equal to 1. Permutations. The different arrangements of a given number of things by taking some or all at a time are called permutations. Example, all permutations or arrangements made with the letters A, B, C by taking two at a time. A, B, B, A, A, C, C, A, B, C, C, B. Example, all permutations made with letters A, B, C, taking all time of A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Number of permutations. Number of all permutations of n things taken or at a time is given by NPR. NPR equal to n into n minus 2 and so on n minus r plus 1. It's written as n factorial divided by n minus r factorial. NPR equal to n factorial divided by n minus r factorial. 6p2 equal to 6 into 5. 7p3 equal to 7 into 6 into 5. 7p3 can be written as 7 factorial divided by 7 minus 3 whole factorial. By simplifying, we get 210. So, and number of all permutations of n things taken all at a time equal to n factorial. An important result, if there are n objects of which p1 are alike of one kind, p2 are alike of another kind, p3 are alike of third kind, and so on. And P are all alike of odd kind, such that P1 plus P2 plus and so on P are equal to n. Then number of permutations of these n objects is n factorial divided by P1 factorial into P2 factorial and so on PR factorial. That means n factorial divided by the factorials of alike terms P1 factorial, P2 factorial and so on PR factorial. Next, combinations. Each of the different groups or selections which can be formed by taking some or all of a number of objects is called a combination. Suppose we want to select 2 out of 3 boys, A, B, C. Then possible selections are A, B, B, C and C, A. Note that A, B and B, A represent the same selection. Example, all the combinations formed by A, B, C, taking 2 at a time are A, B, B, C, C, A. The only combination that can be formed of 3 letters A, B, C taken all at a time is A, B, C. Another one, various groups of 2 out of 4 persons A, B, C, D are A, B, A, C, A, D, B, C, B, D, C, D. Note that AB and BA are two different permutations, but they represent the same combination. And number of combinations. The number of all combinations of n things taken or at a time is NCR. NCR equal to n factorial divided by or factorial into n minus or factorial. N factorial divided by or factorial into n minus or factorial is equal to NCR. Note that NCN equal to 1 and NC not equal to 1. An important result NCR equal to NCN minus 1. We can written NCR as NCN minus R. These all about permutations and combinations. Next topic, probability. Here probability, uh, we heard about experiment, random experiment, rolling and examples of performing a random experiment, rolling an unbased die, tossing a fire coin, drawing a cord from a pack of well shuffled cords, picking up a ball of certain color from a bag containing balls of different colors. So, details, when we throw a coin, then either a head, hedge, or a tail T appears. A dice is a solid cube having 6 faces marked as 1, 2, 3, 4, 5, 6 respectively. When we throw a die, the outcome is the number that appears on its upper face. And a pack of cards has 52 cards. It has 13 cards of each suit, namely spades, clubs, hearts, and diamonds. Cards of spades and clubs are black cards. Cards of hearts and diamonds are red cards. There are 4 corners of each suit. These are ace, kings, queens, and jacks. These are called face cards. Sample space. This is also a important thing. Uh, Experiment, an operation which can produce some well-defined outcomes, is called an experiment. And random experiment, an experiment in which all possible outcomes are known and the exact output cannot be predicted in advance, is called a random experiment. Sample space, when we perform an experiment, then the set S of all possible outcomes is called the sample space. Example, in tossing a coin, sample space head, tail. If 2 coins are tossed, then sample space equal to head, 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 tail, tail, head, tail, tail. In rolling a die, we have S equal to 1, 2, 3, 4, 5, 6. Next, event. Any subset of a sample space is called an event. Let S be the sample space and let E be an event. Then P of E equal to probability of occurrence of an event. P of E equal to N of E divided by N of S. Results on probability. P of S equal to 1. Condition 0 less than or equal to P of E less than or equal to 1. P of null equal to 0. For any events A and B, we have P of A union B equal to P of A plus P of B minus P of A intersection B. If A denotes P not A, then P of A not equal to 1 minus P of A. This is all about probability. And next topic is true discount. So, true discount, suppose a man has to pay rupees 156 after 4 years and the rate of interest is 14% per annum. Clearly, rupees 100 at 14% will amount to rupees 156 in 4 years. So the payment of rupees 100 now will clear off the debt of rupees 156 so due for due 4 years. Hence, we say that sum due equal to rupees 156 due 4 years hence. Present worth equal to 100. True discount equal to 156 minus present worth 100 equal to 56. Sum due minus present worth. That's true discount. We define true discount equal to interest on present worth. Amount equal to present worth plus true discount. Mm, Interest depends on present worth and true discount is depends on the amount. And formulas here to remember, let the rate equal to or percent per annum and time equal to 2 t years. Then present worth equal to 100 into amount divided by 100 plus rate into time. Simply 100 into TD divided by 100 into TD divided by R into T. True discount TD equal to PW into R into T divided by 100. It's also written as amount into R T divided by 100 plus R into T. Sum equal to SI into TD divided by SI minus TD. SI minus TD equal to SI on TD. SI means sum due. When the sum is put at compound interest, then present worth equal to amount divided by 1 plus or by 100 whole power t. This is about true discount. Next, banker's discount. Here, banker's discount. Suppose a merchant A buys goods worth say rupees 10,000 from another merchant B at a credit of say 5,000. 5 months. Oh, sorry. At a credit of 5 months, then B prepares a bill called the bill of exchange. A signs this bill and allows B to withdraw the amount from his bank account after exactly 5 months. The date exactly after 5 months is called nominally due date. 3 days, known as grace days, are added to it to get a date known as legally due date. Suppose B wants to have the money before the legally due date, then he can have the money from the banker or a broker who deducts simple interest on the face value with a SI sum due. Mm, Rupees 10,000 in this case for the period from the date on which the bill was discounted, that is, paid by the banker, and the legally due date. This amount is known as banker's discount. Thus, banker's discount is the simple interest on the face value for the period from the date on which the bill was discounted and the legally due date. Here, banker's gain equal to BD minus TD for the unexpired time. Note: when the date of the bill is not given, grace days are not to be added. Here, banker's gain equal to simple interest on bill for unexpired time. BG. Banker's gain equal to BD minus TD. Banker's discount minus true discount. BC equal to TD whole square by PW. TD equal to root of PW into BC. Banker's discount equal to amount into rate into time divided by 100. True discount equal to amount into rate into time divided by 100 plus rate into time. Amount equal to PD into TD divided by PD minus TD. True discount equal to BG, banker's gain into 100 divided by rate into time. Banker's discount concept. Next, heights and distances. We already know that in a right angle triangle, sine theta equal to perpendicular divided by hypotenuse. That means opposite divided by hypotenuse. Cos theta base divided by hypotenuse. Tan theta opposite side by base. Cosecant theta 1 by sin theta. Secant theta 1 by cos theta. Cot theta 1 by tan theta. Cosec, sec and cot or reciprocals of sin, cos, tan. Here, trigonometric identities. Sin squared theta plus cos squared theta equal to 1. 1 plus tan squared theta equal to secant squared theta. 1 plus cot squared theta equal to cosecant squared theta. Next, values. Sin 0 equal to 0. Sin 30 1 by 2. Sin 45 1 by root 2. Sin 60 root 3 by 2. Sin 91. Cos 0 1. Cos 30 root 3 by 2. Cos 45 1 by root 2. Cos 60 1 by 2. Cos 90 0. Tan 0 0. Tan 30 1 by root 3. Tan 45 1. Tan 60 root 3. Tan 90 undefined infinity. And reciprocals of these are remaining values, cosec, sec values and cot values. And the next concept here, angle of elevation. Suppose a man from a point O looks up at an object P placed above the level of his eye. Then the angle which the line of sight makes with the horizontal through O is called the angle of elevation of P as seen from O. Angle of elevation is placed above the level of his eye. And angle of depression. Suppose a man from a point O looks down at an object P placed below the level of his eye, then the angle which the line of sight makes with the horizontal through O is called the angle of depression P as seen from O. This is heights and distance concept. So we covered many concepts. In the odd man out series, you can find it out odd man out. The topics I covered in whole video. I will repeat again the topic names for your reference. Numbers, HCF and LCM of numbers, decimal fractions, simplifications, square roots and cube roots, average, pro, uh, assets indices, percentage, profit and loss, ratio and proportion, partnership, chain rule, time and work, pipes and system, time and distance, problems and tries, boats and strings, allegation and mixture, simple interest, compound interest, logarithms, area, volume and surface area, races and games of skill, calendar, plots, stocks and shares, permutations and combinations, probability, to discount, bankers account, heights and distance, or none of these. Maybe I haven't forget about crops also I think so. So let me tell you in brief about that also. Yeah. Crops, crops here. The face or dial of a watch is a circle whose circumference is divided into 60 equal parts called minute spaces. A clock has two hands. The smaller one is called the hover hand or short hand, while the larger one is called the minute hand or long hand. In 60 minutes, the minute hand gains 55 minutes on the hover hand. In every hour, both the hands coincide once. The hands are in the same straight line when they are coincident or opposite to each other. When the two hands are at right angles, they are 15 minute spaces apart. When the hands are in opposite direction, they are 30 minute spaces apart. Angle traced by our hand in 12 hours equal to 360. Angle traced by minute hand in 60 minutes equal to 360. Too fast and too slow. If a watch or a clock indicates 8.15, then the correct time is 8. It is said to be 15 minutes too fast. On the other hand, if it indicates 7.45, when the correct time is 8, it is said to be 15 minutes too slow. So, our aptitude learning concept entirely completed. Now, I will give you guarantee. With these concepts, you can uh, solve any problem confidently. So, this is only audio based learning. Here, I haven't shared any slide. This is just see you in next amazing topic.